Guys, welcome back to Mr. Bull's Physics channel. It feels like a family. Hashtag physics is family. Today's lesson is going to be just going through the past paper questions that I gave out to you at the beginning of the week and kind of going through them step by step together. Now, before I do that though, I thought I would like to give you 3 physics jokes I think are particularly hilarious. I'm not gonna lie, particularly hilarious. And I'm gonna label them 1, 2, and 3, and then you're gonna comment below on which one you think is the funniest, okay? And then we'll see how it goes. Now, the catch is I'm gonna give you all 3 questions to the jokes, and then I'm gonna answer them or give the punchline after I've gone through the past paper questions. All right, so you're gonna have to watch the video to get the answers. All right. So, joke number 1 is this. What is the name of the first electricity detective? Okay, what is the name of the first electricity detective? Number 2 is, where does bad light end up? So number 2 is, where does bad light end up? Okay, and the last one, is, what is a physicist's favorite food? What is a physicist's favorite food? Okay, those are your 3 jokes. Watch the past paper questions and we'll jump back for the answers. Okay, it's time to get into this National 5 and go over these past paper questions. Now, if you're stuck on a particular question, 1, 2, or 3, maybe you're not stuck with 1, or stuck with 3, I put chapters in the YouTube video, so you can just skip to that question. And in the description, you can see also where that time comes up, so you can skip through to the ones you actually need help with. Now, let's go over these questions, okay? Number 1, and number 1 is just going to come off to the side here. You'll just see it kind of popping over here, and I'll keep that up for the duration of question 1. It says a student connects a mobile phone to a speaker wirelessly using a microwave signal. So it says the time taken for the microwave signal to travel from the mobile phone to the speaker is 2.1 times 10 to the negative 8 seconds. Calculate the distance between the mobile phone and the speaker. So let's just do 1A, okay? And it's going to be distance equals speed times time. The velocity is 3 times 10 to the power of 8 because it's an EM spectrum wave, and the time is 2.1 times 10 to the negative 8. Okay, now I'm just going to realize that they are the same powers, or well, they're going to cancel each other out almost. So 3 times 2.1 is 6.3 meters, which is the correct answer. Okay. Right. B, sound is a longitudinal wave. Okay, what is meant by the term longitudinal wave? Well, this is a definition that you should just know. It's in your booklets. So a longitudinal, there we go, hard to spell, wave is a wave. That'd be good if it was just that definition, but it's not. That moves, and here's the key word, parallel to the direction of motion. Okay? That would get you the mark. So that's a key definition. Make sure you remember the one for transverse wave as well. Then B2 says determine the wavelength of a sound wave. Now, just looking at the sheet over here, you will see that the wave, longitudinal wave, is actually split into waves that we can actually take out from there. So you can see that actually from crest to crest, where the waves bunch up together, that's a wave. So looking at that, there's 4 waves. All right, there's 4 waves in that 0.272. So all I'm going to do here is, if there's 4 waves, then 0.272 divided by 4 gives me 0.068 meters. Okay, that's that there. So that's a fairly straightforward question once you kind of see that that's what it's asking. And then for 3, calculate the frequency of the sound in air. We're going to do F equals V over lambda. Now this is where people might get caught out. V is no longer 3 times 10 to the power of 8 because we're talking about a sound wave, so it's 340 now, divided by 0.068 8 gives me 5,000 hertz. Okay, so answers here 6.3, make sure you have the parallel in there, 0.068 and 5,000. Alright, so that is question 1. That is question 1. So let's now move on to question 2. And question 2, let's just do a fresh piece of paper here. So question 2 is again another wave question, because that's what we've been looking at. So I'm going to do 2A up there. Yeah, you can see that. That's good. So first question asks, to determine the frequency of the waves, the student measures the time taken for a wave to pass a point at the harbour entrance. The student measures this time to be 2.5 seconds. Calculate the frequency. Well, this is for one wave. For a wave is one wave. Okay, so it's just going to be F equals 1 over T. All right. Now, just as a wee pointer, I'm going through this fairly quickly because you've gone through this. Okay, you've done S3 work before. If this is my S3 class, I'd be going more steadily, but this is stuff you have done and it's revision. Okay, so I'm showing you how to do the answers, and you can go through and stop it and pause it if you need to. But 1 divided by 2.5 gives me 0.4 hertz. Okay, then B says suggest how the accuracy of the frequency determined by the student could be improved. Okay, this is actually double I, so why not I just do double I over here so we don't get mistaken. Alright, so one thing that could be improved is the person's only counting one wave. You know in your physics that counting one wave is probably not going to cut it, so you need to count multiple waves. So I'm going to say count multiple waves over a larger period of time. And then use F equals N over T. That would be a perfect 1 mark answer. Alright, so make sure, there's probably a couple of other ones you could do as well, but I think that's what they're trying to ask, okay, which is good. So B now says, the distance between one wave crest and the next crest is 8 meters. Calculate the velocity of the waves. Okay, so the equation we're going to use here is V equals F lambda, because we know that the distance between the crests is the wavelength, and that's given as 8. So 0.4 times 8 gives me 3.2 meters per second. Okay. C then asks us to complete a diagram. So let's just draw that diagram out. So we've got there we go. And so we've got a wee wall here. Straight lines coming through. You should have something like this. Now this is diffraction. You know this is diffraction. The bending or spreading of waves as it passes through a gap. Okay, so that should be C. And then last but not least, let's do D over here so it's nice and visible. It says, as the wave passes into the harbour, the student observes that the amplitude of the wave decreases. Explain this observation. Well, you should know that amplitude is connected to one other thing that we look at in waves, and that is energy. So if I was to answer this, I'd be, as the waves pass through the gap, the energy of the wave decreases. As the waves pass through the gap, the energy decreases, and so too the amplitude. Alright? Perfect. Alright, so if we were to look at this, answers 0.4 hertz. Okay, multiple waves in longer time period, 3.2 meters per second. Making sure you have those curves there, and the energy of the wave decreases. Alright, so that's that. So that's question 2 done. And then last but not least, if I can even get this turned, is question 3. Okay, now 3 should be fairly straightforward. Come on. Full marks here, surely. Set a detector of infrared radiation. Okay, remember, it's just over here. Set a detector of infrared radiation. You should know, every single time, thermometer. Thermometer. Just always remember that, please. It's just a thermometer. Alright? B says state which radiation in the EM spectrum has a wavelength shorter than X-rays. Gamma. Or gamma rays, just to be exact. Okay. Then C1. An EM wave has a frequency of 1.2 gigahertz. Show that the wavelength of this wave is 0.25 meters. Okay, so it's a show that question. So we're going to show that by just doing lambda equals V over F. That is 3 times 10 to the power of 8 divided by 1.2. This is the giga, which is times 10 to the power of 9. And I get 0.25 meters, exactly what I hoped I would get. Okay, and then II, identify the part of the spectrum that this wave belongs to, and that should be looking at our kind of EM spectrum here, looking at the bottom line. You should identify that this is actually corresponding to microwaves. All right, National 5, boom. Done. Okay, perfect. Answers all nice and straightforward there. The only one I need to highlight there is that one there. So that should be the answers and the run through for Waves Part 1. An easy introduction, but stuff that you've not done for a long time. Alright, well done, National 5. Alright, that is the past paper questions answered. And the moment you have been waiting for is here. Let's look at those punchlines. So question 1 was, what is the name of the first electricity detective? Of course, it's Sherlock Holmes. Come on, Sherlock Holmes. I know you're laughing back there. Number 2 is, where does bad light end up? And the answer is in a prism. Come on. That has to be the winner. In my book, that is the winner. That's a classic. And the third one is, what is a physicist's favourite food? It's fission chips. This is the National 5 course in joke form, everybody. So, whatever one is your favourite, put it down below in the comments, okay? I'm going to put down number 2, because that is definitely my favourite. Alright, guys, I hope you had a good week. I'm looking forward to doing some more videos for you next week. Get subscribing, get sharing, get liking, put notifications on. These videos are premiering every Monday, Tuesday and Thursday. Guys, have a good weekend and I'll see you later.